A very good morning to all. So today we are going to see the topic from Unit 1 in the subject Basic Electrical and Instrumentation Engineering. The topic is generation of three-phase EMF in the three-phase circuit. So what is the definition for generation of three-phase EMF is? Here how the three-phase EMF is generated here means yes. So when the interaction between the rotating magnetic field and conductor, which should be arranged in specific manner, then only a EMF will be introduced. So typically a three-phase AC generator, how it will be constructed means the magnetic field will be rotated within the three sets of stationary coil. This stationary coil is uh, placed at the degree of 120-degree interval. Next. So what is the principle behind this EMF generation is? The principle behind this Faraday's law of electromagnetic induction. What it states that means electromotive force will be induced in a conductor when it is exposed into the changing magnetic field. So what does it means that when a magnetic field is there, if you are placing a conductor in this magnetic field means there is a testing moment will be occurring. So in this three-phase generator, here the the rotor creates the changing magnetic field that will interact with the stationary coil, which is placed separately. So the EMF introduced in the individual coil will be in the form of sinusoidal nature. Here, as we told earlier, each stationary coils are placed 120-degree apart. So you will get three sinusoidal waveforms at 120-degree difference. So this one shows the uh, diagram of the three-phase generator or generation of three-phase EMF. Here it shows that the magnetic field is fixed. So this is a north pole and south pole. Here you have three conductors. What are they means? A2 and B2, C1, C2. So these are the three conductors which is placed inside the magnetic field. The placement of three conductors are 120-degree apart. You can see that so the angle between A1 A2 conductor and B1 B2 conductor is 120-degree, and B12 and C1 C2 conductor is 120-degree. And this diagram also shows that here your magnetic field is rotating, the stationary coils are fixed here. So what are the basic components in three-phase generation is rotor, stator and magnetic field. So rotor is nothing but a rotating part of the generating system which will create the changing field. So stator is nothing but it is a stationary part of the generator, so where the windings are placed to produce the EMF. So, so what is nothing but in a rotor it will generate it will create the magnetic field. In stator we will get the EMF produced will be get from this stator. So what is magnetic field is? The magnetic field will be created by the rotor, which will interact with the stationary winding in order to EMF will be generated. So as I told you earlier, so we have three conductors, so A1, A2, B1, B2 and C1, C2. So A1, B1, C1s are we called as a starting terminal, A2, B2, C2s are we called as a finishing terminal. So each conductors are placed 120 degree, and once you are rotating, that is magnetic field is rotated anti-clockwise direction, the EMF will be introduced in the respective coils. So this is the EMF introduced in the three coils. So this one shows the EMF introduced in the first conductor, that is A1, A2. So it starts from the angle of 0 degree. If you see the second conductor B1, B2, it starts 120 degree apart from first conductor. If you see the third conductor, means the EMF produced will be 120 degree apart from the first conductor and 120 degree apart from the second conductor. So what we infer is, so you can see that at the origin, that is in 0 degree, the conductor 1 starts at 0 degree, and the second conductor starts increasing from negative portion to and reaches the maximum portion in the negative side, and it goes on decreasing and reaches 0, and it goes on increasing in the positive direction. If you see the third conductor at the 0 degree, means it will be in positive side. It starts decreasing from positive side and reaches the 0, and it goes on negative direction and reaches a negative peak, and it reaches the 0 angle. This is what we discussing here. So what are the things we have mentioned here? Actually A1, A2, 0 start at 0 degree and it is increasing in positive direction. And the coil B1, B2 is start 120 degree electrically behind the coil A1, A2. As we told that the coil is in negative direction and it becoming negative as it is shown in your waveform. So this is the EMF equations. For first coil, there is a no difference in the phase angle. So your EMF produced in the first coil will be EM sin omega t. In second coil, it is 120 degree apart. So we are writing EM sin of omega t minus 120 degree. For third coil, EM sin of omega t minus 240 degree, or otherwise we can write EM sin of omega t plus 120 degree. So this is the phasor diagram. For drawing the phasor diagram, we are taking the A1, A2 as a reference. So it will be in the reference line. The second conductor produce 120 degree apart. So this is the EMF introduced in the second coil. From this 120 degree, you have a third coil. If you see the angle between A to C will be also 120 degree. So during the construction itself, we inform that three coils are placed 120 degree apart. So if we see the angle between each conductor, means it will be 120 degree, 120 degree. So what are the advantages in three-phase generation is it have a high efficiency if we compare to the single phase. So these are the efficiency we are getting. It will have a high efficiency. It will give constant power. What does it means that in single phase we won't get the constant power, and reducing the energy loss. If you see the design, means it will be compact and then it will be smoother operation and it cost effective one. So thank you all.